Hello 108 class, Mr. McHugh here with you, back on section 9.6, going to do an application problem on page 7 of our class notes, and this is on page 545 out of your book. And so I have a little rough diagram here, but let me read the problem here to you. We got a barn and a farmer. Let's say you have a friend, he's got some land out there in the country somewhere and has a barn, and he is out at D&B Supply and can buy 120 feet of fencing. Think of this as being rolled. It's a deal. He's going to either buy it now, or it's going to be gone. He's trying to decide whether or not it's worth his while to do it. So I'm trying to get some application going here. I'm ad-libbing to the problem a little bit, but pretend you've got 2 horses and you're thinking about, you got your barn, you don't know the length of it because you forgot to take the measurement. It's kind of an impulse buy. Is it a good buy or a bad buy? If he buys this fence and doesn't use it, then he wasted his money. If it works out for him, then it's a good deal. Can you help him out? So here's the story. He has 120 feet. If he buys it, he's going to bring it home. He wants to, let me get back in here. X represents the length, the width. Oh, let's use the right measurements. The width from the barn. The barn length we don't know. Okay. 3 sides. We're doing 3 sides. Going to take advantage of the barn to be the 4th side to enclose the horses. I say doggies, but nothing wrong with either way. I'm only saying horses because I know, and I don't have horses, maybe so they could tell me, but you need to have so many square feet for a horse to be comfortable with for them, so they can eat and graze around and move around and stuff. So here's the question. What would that length be? How can we represent that? Now, come over here, think about this for a second. The width plus the width plus the length all has to equal what as far as the fence goes? 120 feet. He's going to buy that rolled out fence. So let X represent the width. So X plus X comes down as the 2X plus the length equals 120 minus 2X on both sides. And lo and behold, the length has got the relationship 120 minus 2 times the width. Okay, so it's kind of important that you get that right. I think that's a key part of the problem, because now that you know that this can be represented as the length, we need to figure out the area. They need to know the maximum area. Now here's what they're talking about. If you take this fence and, oh, let me go to a different color here now since I'm getting into my color scheme. Let me just go green. What if you took the fence and you went like this, out a little bit, and you went like this? Well, if you left it open, then the horses would go out, right? And if you turned around and said, well, I'll run it this way, I'll come like here and stop it, and you run out at 120 feet, what did you do? Okay, so you got to enclose it. That's what they mean by that max. So now we go back to the area of a rectangle is width times length. Okay, we know that from our toolbox. Area equals width times length. And now for width we're putting X, and for length we're putting the relationship 120 feet minus 2 times the width. Okay, now multiply this out with the distributive property. Next thing you know, you get 120X minus 2X squared. Rearrange the rearrange the terms so you got a quadratic equation and exponents in descending order, and boom, A, B, C are your coefficients. Okay, now the next part of this is to find this area. They want you to realize that that maximum area is going to be found with the right width on the x-axis and the area on the y-axis. So it's going to be a parabola going like this, and we want to find that, I call it the sweet spot. That's what we're trying to look for. So now we know what the definition of vertex is. It's always the max or the min. In this case, it's going to be the max. So we will find negative b divided by 2a. And that's the line of symmetry again, but that's where the vertex is going to sit. And then once we find that value, we're going to put it in and find the function of area relative to that value, negative b divided by 2a. Okay, so the good news is once you understand the strategy to the problem, it's not too bad. You could be out there with your friend, got your calculator going in your head. Next thing you know, you labeled A, B, C, which I had done up here as negative 2, 120, and 0. Substitute in negative 120 divided by 2 times negative 2. Everybody getting all the substitutions going in. It all equals what? Negative 120 divided by negative 4, positive 30 feet. There you go. Boom, just like that. You tell him it could be 30 feet wide. And he's impressed by your math skills. Good job. You helped your friend out. Okay. To me, that's where mathematics comes in hand here, because now he knows 30 feet. He also wonders, well, what's the square footage going to be? Because if it's not enough, then I can't keep my horses in there. Okay. And the other thing is, maybe 30 feet, depending on where his property, maybe 30 feet's too much. Maybe he's only got 20 feet of property. You don't know for sure, but if he knows this information, he's armed with the information, then he can make an intelligent decision. And I think that's where mathematics helps out. It helps you make intelligent decisions with your logic reasoning capability. So 30 feet, plug it in. So we got negative 2 times 30 squared plus 120 times 30. Okay, now we're in arithmetic mode. 30 squared is 900 times negative 2 is negative 1800 plus 3600. Add them up. Boom, 1800 square feet. So just like that, you've been able to tell your friend he can have a width of 30 feet and you'll have 1800 square feet. Okay, so I'm just making this up I'm making this up now, but and if you have horses, I'm just making this up because the math's easy. What if 600 square feet is enough for one horse? Okay, just pretend. What would that tell them now? 6 goes into 18 what? 3 times? Therefore, he knows he could have 3 horses. Could be taken care of in there. Okay. I think that's a fun problem there. So we wrapped this up. It was all on page 7. And we're going to continue on with page 8. We're going to do some more applications. This one is one that gets me all hot and bothered because it's maximum height of missiles. And I've got stories to tell you about my Aegis stays and us changing the system to shoot down ballistic missiles. Okay. Take care, and I'll see you then. Bye-bye.